Hey guys, this is Jim, WT1W, and you're watching FEPLabs Radio. Thanks for stopping by. Appreciate it. So today I want to share a few tools with you guys that I think are an essential part of everyday life, as well as useful in ham radio. And these tools are not really that expensive. You can get higher end versions of them. You can get lower end versions of them. But I want to take a look at all three of these and show you how we would use them. So the first thing I want to share, and I'm going to switch to an overhead view here so we can get a close-up look at all of these. First thing I want to share with y'all is a clamp meter. And I've done a review on clamp meter before, one that was sent to me by a vendor, I don't remember who. This is one I purchased. This is a Tesman clamp meter, and this is special because it has a thing called Inrush current on it. Some meters may also call this max min. When you're checking AC current, you may have a higher initial current when an object starts up than when it's running. Now, typically this is something like an air conditioner or something with a motor or a compressor in it, and you're going to have a heavier inrush current. Heaters can also do that, and we're going to take a look at this in a minute. The other thing I've got two more gadgets here. This one is a plug tester. Let me see if we can get that to focus on this thing. And this is a Klein Tools. All you simply do is plug this in an outlet, and it will tell you if the outlet is wired correctly or not. You know, our radios are plugged into power supplies on DC, but those power supplies, which can be kind of pricey, are plugged into an AC wall jack, typically. Fancier radios have an inbuilt power supply, and they would go in straight to the AC wall outlet, but most of us have something that runs off of a DC power supply. I have a Flex radio. It runs off of a DC power supply. It does not have an inbuilt power supply. In any case, this will let you check that. The last thing I wanted to share was the thing I learned about only recently. Did not know about this. And this is called a line splitter. And we're going to look at how this works in a minute. This lets you measure AC current with a clamp-on meter without having to separate wires out. If you find the last video, and I'll put a link up here in the dingus somewhere above to that video where I originally tested a clamp meter, I had to make what I refer to as a danger cord. Because it's AC and the current alternates, you can't put the clamp meter straight around the power cord because the alternating current cancels it out. And the way this deduces current, you read no current even though the item is probably on and operating fully. So I had to strip the insulation off of a power cable so I could clamp around just the hot wire to test it. This eliminates the whole need for a danger plug of any kind. So we're going to take a look at all three of these. Stick around. So this is the outlet tester, and when you turn it on, it does take a battery. I believe it's a 9-volt. And it will tell you 0 and open and hot, whatever it says on the screen there. And we have no indications on the screen at all. Our outlet tester, and this is the GFCI outlet in my bathroom. Sorry for the echo. So if we plug this in and turn it on, it's going to turn on. It's going to check our outlet and tell us that we have 122 volts and everything is wired correctly. Awesome. So now if I come over here and I press test, it should trip our GFCI. And you saw it trip right there. And of course it's gone down to 0 volts because it's got a GFCI trip. If I reset the outlet, we're back to green once again. Also, if I do the test this way, it will fault because it detects that the GFCI outlet is tripped. Reset. And once again, we're good. So that is what the outlet tester does. I put it on the GFCI outlet so we could see what it did, but it shows you the voltage, and the green light tells us that the wiring is correct. And if we pull this out, the documentation that comes with it tells us what the lights mean, and there's some different patterns that it will flash, and it will say what it's doing on the screen. Now, I have for testing here a space heater. And because of camera space, I'm going to set it on the floor. down here by my feet, and we're going to plug it in. But what we are going to do is plug it in the line splitter after we plug it in straight to the cord. And I don't know if you heard the beep, but it powered on. And I'm going to turn it on, and we're going to fire up our meter without using the line splitter. And I need to go to manual mode, and I need to select Inrush. Actually, we don't even need Inrush right now. And if we go to test our current, it says we're using 0.11 amps of current draw. There's no way this space heater is pulling only 0.1 amps. That is not correct. And that is because we're reading both the hot and the neutral at the same time, and it's essentially canceling each other out. So let's disconnect it, and let's plug in our line splitter. And then let's plug in our heater. And now let's turn on our heater. That shows up pretty good on camera. And there we go. That's much more what I expect. And you can see the current went down from when we started. So that is what's called Inrush, that higher amperage on initial startup of the appliance. This is not typically a thing in amateur radio, the Inrush function. I have some air conditioner work I need to do while it's not 100 degrees outside, and I needed something to check Inrush. So that's why I bought this meter. It specifically does Inrush. All right, let's cut this off. We're back up to 12 amps now. I'm getting verklempt. It's warm in here. So now, if we set our meter to Inrush select, and you can see that you can't see it too well, but it lit up the word Inrush right there on the meter. And now let me turn on the heater. And we pulled initially 12.1 amps. So if I turn that off, it will show our current draw. So that's going to change as the heater, of course, cycles up and so on and so forth. But Inrush is something that a lot of inductive type things are going to have when they fire up. Again, like a motor, a compressor, your refrigerator, for example. And I know, let me turn off this heater. A lot of us have generators, or we're running on solar generators, regular gasoline or gas generators. And anything you hook up, like an air conditioner or furnace, is going to have some amount of inrush current. So there's a lot of RV people And then this particular meter, besides the Inrush function, it also has auto. It will take probes, which it comes with a set of probes as well as a thermocouple, AC and DC voltage. It also does temperature in Celsius and Fahrenheit, millivolts, hertz. It will do inductance, capacitance, voltage, resistance, continuity, so on and so forth. All the things a standard electronic meter will do. Nothing special there. It also has a non-contact voltage tester. So if I flip it over to NCV mode, I think I have to put it in NCV mode. It won't do it automatically. NCV, there we go. NCV. And it should tell me that this is hot. And you can see the light comes on and it starts beeping, which means we have electricity there. So that is what NCV mode is. And of course you can leave it in auto, and as I said, it does all the standard functions. This was $29. This was not an expensive meter. Now, one thing I learned also after I bought this, which I was also kind of unaware of, is that a lot of the clamp meters that are sold, and you need to watch out for this, it may matter to you, it may not. This does not measure DC current with the clamp portion of the meter. There's a separate one that they sell that does, and it's about $56 instead of $29. Had I been paying attention that day, I would have bought the one that does AC and DC current that way. Why would you want something like this? Even a cheap one that only does AC? Because most meters will do current measurements, right? Your average multimeter, the video I did on that old Simpson meter, will do current measurement, AC and DC current measurement. Why would I want something like this? The answer is easy. Most of those meters, the amount of current they can measure is 10, maybe 20 amps of current. This is rated up to 600 amps. So you get a lot more range as far as DC current measurement. The ham, I don't know that you're going to care about that specifically. Again, maybe in the off-roading RV arena, that would matter more. As a homeowner, it matters to me. I recently wired in a 240 circuit out in my shop so I could move all my radio stuff out there and put my amp on 240 volts. So I wanted to make sure that what kind of current I was pulling, so I knew that I sized the breaker appropriately. So again, this is also a whole lot safer than sticking meter probes in line while you're trying to test current draw on a device. So that's why I feel that this is something everybody should have. Now, of course, the line splitter here, this is only for a standard 110 style plug. This isn't for any of the oddball 220 plugs. So you'd have to get one that was designed for 240 volts. I'm sure they make one. I don't really need it. I just tested each leg separately when we were pulling the wire before I cut everything down and finished putting it in the panel. In any case, guys, those are 3 useful tools that I think everybody should have in their toolkit. Not radio specific exactly, but something that a homeowner should have. And if you live in a building somewhere, I think you should have these in your toolkit. Guys, that's all I've got in this video. If you would give me a thumbs up, please make sure you're subscribed to the channel. I certainly would appreciate it. And ring the bell so you get notified whenever I post any new videos. Thanks a lot, y'all. 73.